We're going to do some basic, simple speed of light questions, and here's our first question. It's how far will light travel in 1 year? Okay, so first off, the formula for speed is d equals v times t. Now, the speed of light actually, for a vacuum, is the symbol would be c, which stands for 3 times 10 to the 8 meters per second. So our equation is going to look something like this. It's going to be d is equal to v, which is really c, which is 3 times 10 to the 8 meters per second times time. Now, what's time? Time is 1 year, so it's 1 year. And 1 year is 365 days. So it's 365 days per year, which is 24 hours per day. 24 hours per day. And that is 60 minutes per hour. So 60 minutes per hour. And that is 60 seconds per minute. And we're going to have to convert all of this. Now you'll notice the units are going to cancel. So years will cancel out with years, days with days, hours with hours, minutes with minutes. So you're just left with seconds. Alright, so if you work all of this out, then you get an answer of d is equal to 9.5 times 10 to the 15. And that would be meters. Or 9.5 followed by 14 zeros. Okay, next question is how long would it take light to reach us from the sun? So the sun is about 150 million kilometers away. How long will it take? Well, we can rearrange the first equation to say something like this. T is equal to d over v. The number v is, we're actually using c. So the distance is 150 million kilometers. Okay, and that is over the speed of light. But now, we could use a different unit, which is 3 times 10 to the 5 kilometers per second. Okay, so what is that? That's the same thing as saying 150 kilometers over 300,000 kilometers per second. Okay, and that gives you an answer of 500 seconds. Which is over 8 minutes. So take light over 8 minutes to get to us. Okay, next question is how far is a planet if a radio signal takes 2 hours to get to us? A radio signal would be traveling at the speed of light. So it's d equals v times t, again where v is really c. So we could say v times t, so it would be c would be 300,000 kilometers per second. And times 2 hours. Now 2 hours, we need our unit to be in seconds, so it would be 2 hours times 60 minutes per hour times 60 seconds per minute. And again, like before, this cancels out to give you an answer in just seconds. Alright, so if we work this out, our distance is 2,160,000,000. So that's 2,160,000,000 kilometers. Okay, next question is how far is Andromeda, our closest galaxy, which is 2.6 million light years away. Now, in this question, we already know what a light year is. We know a light year is, so 1 light year is equivalent to 9.5 times 10 to the 15 meters. So it would stand to reason that 2.6 million light years would be 2.6, which is 2.6 times 10 to the 6 million light years would be 2.6 times 10 to the 6 times 1 light year, which is 9.5 times 10 to the 15 meters. So in this case, the answer is going to end up being 2.47 times 10 to the 22 meters, which is just an incredibly large number. So for this question, you could have used d equals v times t, but then you would have to do a lot more work. It would have just been easier just to take the distance of 1 light year, which we know what it is from the first question, and just multiply that by the length of time, which is 2.6 million light years. Talk about the index of refraction, which is a measurement of it's a ratio basically of the speed of light in a vacuum, which is c, over the speed of light in another medium. So in this case, the diamond has an index of refraction of 2.4. What that means is that light will slow down by a factor of 2.4 when it travels in a diamond. So what we can do is actually calculate the speed of light in a diamond by using this equation. So first off, we're going to rearrange it. We're going to solve for v. So v is going to equal c over n. Okay, so v is equal to c over n. We know what c is. We know c is 3 times 10 to the 8 meters per second in a vacuum. And we know n is 2.4 because we're given n in this equation, in this question, sorry. So in this case, this gives us an answer of b is equal to 1.25 times 10 to the 8 meters per second. So what this is telling us is that the speed of light in a diamond is 1.25 times 10 to the 8 meters per second. All right, so now let's take a look at this question. What is the index of refraction of some substance? There's no name for the substance. If the speed of light in that medium is 225 million meters per second. So let's take a look. So the equation for the index of refraction is n equals c over v. We know what c is. We know c is 300 million meters per second. And we're told that in this substance is traveling at 225 million meters per second. So this will give us an answer of 1.33. That means that this substance slows down light by a factor of 33%, which happens to be, by the way, the same index of refraction as water. For some lens equations, and first off, we're going to start with a concave mirror. Okay, so here are two equations that we're going to use, and the first one is with regards to the focal length. This is 1 over f is equal to 1 over do, which is the object distance, plus 1 over di, which is the image distance. And this is really important because for a concave mirror, the focal length is positive. For a convex mirror, the focal length is negative. And di for an image that is virtual, this is a negative value. For an image that is real, it is positive. So signs are going to play an important role in being able to figure out these questions. So let's take a look at the example here. It says we have an object, a thumb, which is 8 centimeters in front. The thumb is 8 centimeters tall and is in front of a concave mirror, which has a length of 10 centimeters, and the image is 12 centimeters from the vertex of the mirror. So here's a picture to help understand. The focal length is here. It's about 10 centimeters away, and the image is 12 centimeters away, and it's in front of the mirror, and you'll see why when we do the calculation. All right. So first off, 1 over f. So 1 over f is 1 over 10. Focal length is 10. Is equal to 1 over do. We don't know what do is. Plus 1 over di. And because the image is in front, it's positive. It's going to be 1 over 12. Now we're going to rearrange this. And we're going to say that 1 over do is equal to 1 over 10 minus 1 over 12. And what that's going to give us is 1 over do. We need a common denominator here. So we can say 60, which is 6 over 60 minus 5 over 60. And that's going to give us 1 over do being 1 over 60. Now that's 1 over do. So we have to invert that. So it's going to be do is equal to 60. And this makes sense because it's positive, so it's showing us that it's in front of the image. So the object is really far away. It's 60 centimeters from the mirror. So that makes sense. Okay, so that's A. Now let's take a look at B. Let's do B over here. Okay, what is the magnification? Well, magnification is negative di over do. So it's negative di over do. So negative di is negative 12 over do, which is 60. And that gives us a magnification of negative 0.2. So what this means is that it's 20% the size of the original, and it's negative, which means it's upside down. So if our object is upright, the image is upside down, and that makes sense according to this little diagram. Of course, now we can figure out what the height of the object is. Because we know the magnification, we can say the image height is equal to the magnification, m, times the height of the object. So that would be negative 0.2 times 8 centimeters. 8 centimeters. So that will give us an answer of negative 1.6 centimeters. So we can see that our image is smaller and it's upside down. Okay, so for another concave mirror question. Here we have a person who's using a mirror for makeup. The focal length of the mirror is 17 centimeters. The person's face is 12 centimeters away. So the person's face actually is closer to the mirror than the focus is. Okay, so let's begin. So we're going to rearrange. We're going to look for di. So we're going to rearrange this as 1 over di is equal to 1 over f minus 1 over do. And we're going to check our signs. We know the focal length for a concave mirror is positive, so we don't need to change anything here. Okay, so 1 over di, we don't know what that is equal to 1 over f. 1 over f is 17. 1 over 17 minus 1 over 12. Okay, and we're going to look for a common denominator. So it's going to be, we can cross multiply and say 12 minus 17 all over 17 times 12. So 1 over di is equal to 12 minus 17, which is negative 5, over 17 times 12, which is 204. Now we can rearrange for di, just flip it over, and you get an answer of negative 40.8. The negative sign indicates that the image is actually in the mirror. So it's in the mirror, it's a virtual image because of the negative sign. Okay, now we can look for the magnification. So this was A. We can now look for B. So the magnification for m is equal to it's equal to di over do. And we can solve now for the magnification really simply. Oh, just noticed a little mistake actually in our the way we've set up. It's actually negative di over do, not di over do. So it's negative. So it's going to be a negative di over do. So let's just fix this. This is actually positive. It's negative di over do. Okay. So the negative di says negative over do. Do is 12. So this is going to give us a magnification of 3.4, positive, because negative times negative is positive. So 3.4. So this means that the image is 3.4 times bigger. The positive sign means that the image is also upright relative to the object. Okay. So the last one is we're going to look at for C. What is the size? How big? So we can say hi. Hi is equal to m times ho. So the magnification is 3.4 times the object. The object apparently is 22 centimeters long. So we're going to do 3.4 times 22, and that will equal 74.8 centimeters. Okay, now for a convex mirror or diverging mirror, and the diverging mirror has a focal length of 50 centimeters. But remember, for a diverging mirror, it is a negative focal length. So we're going to make sure that we remember that. So what we're going to do is we're going to look for the position of the image. Now, with regards to a diverging mirror or convex mirror, the image is always going to be smaller than the object. And this is my crude diagram. So we know the image is always going to be virtual, which means it's going to be in the mirror. Now the other thing that we can fall victim to here is their units. We notice that here it's in meters and here it's in centimeters. So first thing we're going to do, when we look for our image position, we're going to look for di. So we're going to rearrange this and say, okay, 1 over di is equal to negative 1 over f minus 1 over do. Now, we've got to make sure that the units are right. So 1 over di is going to equal to negative 1 over 0.5. We're going to convert this to meters, okay? 50 centimeters is 0.5 meters, and the object distance is 10, so minus 1 over 10. Now we're going to solve for di. So 1 over di is equal to, well, common denominator here, we can multiply this by 20, is equal to negative 20 over 10 minus 1 over 10. So that's going to give us 1 over di is equal to negative 21 over 10. Okay, so now when we rearrange and solve for di is going to be negative 0.48. Again, the negative sign indicates it's virtual, it's in the mirror, and it's closer than what it appears. So there's your answer for the image distance. Okay, so that's A. I should write down that. That's A. So let's figure out B. Okay, so B is the size of the image, which is going to be basically our HI. So HI, how big is HI? Well, HI is equal to M times HO. Now, we don't know what M is, so maybe we could do something different. Because if you look at your equation, HI there's also a relation between di over do. Because we know M is di over do, what we could do is we could do this. We could say negative di over do is equivalent to hi over ho. So when we rearrange this, we get hi is equal to negative di over do times ho, where basically di over do substitutes for magnification. So when we do that, we get negative di is negative times a negative 0.48 over the object distance, which is 10, okay, times the object height, which is 1.8, and we get for hi the following: 0.086 meters. Okay, this next question is a bit tricky, so because we're going to have actually two unknowns, but we're going to be able to solve this, no problem. So here we have a question: a converging mirror that produces an image that is twice the size of the object, and the focal length is 20 centimeters. So we can add that in here. But we're not told anything about the object distance, and we're not told anything about the image distance. And this is where we're actually going to have to do a little bit of a substitution. So it says the image is twice the size. So that means our magnification is 2. Now, with a concave mirror, when you put an object within the focal length, you're going to produce a bigger image that's also the same orientation. So we can assume that's plus 2. Now, because we know the magnification, we can actually establish a relationship between di and do. So M, if you recall, M is equal to negative di over do. So we know what M is. We know M is plus 2. So we can say 2 is equal to negative di over do. Or basically what we can say is that 2 do is equal to negative di, or negative 2 do is equal to di. And what we can do now is we can go back to our original equation with the focal length, which is 1 over f is equal to 1 over di plus 1 over do. And now we can go from there, because we know we can substitute now. So we can say 1 over f. Well, 1 over f is 1 over 20. We can say 1 over 20 is equal to 1 over di. So we know what di is. We know di is equal to this. So we can say 1 over negative 1 over 2 do plus 1 over do. And we can look for a common denominator. So we can say 1 over 20 is equal to negative 1 over 2 do plus 2 over 2do. I just multiply this by 2 because you can see that not same common denominator. Not same denominator, so we gotta make a common denominator. Okay, so what does this give us? This gives us 1 over 20 is equal to 1 over 2do. So now what we can do is we can solve for do. So 1 over 10 is equal to 1 over do. So that means do is 10. And because we know what do is, we can now actually plug do back into this equation over here, where di is equal to negative 2do. So now we can solve for di. So di is equal to negative 2 times do, which is 10, and that we get negative 20. So what does this mean? That means our object distance is 10. So this would have been 10 centimeters, and this would appear, although you can't tell in my diagram, that it would be 20 centimeters in the mirror further away. That's why it's bigger.